on this kind of development of impact-based and risk-based public weather services in collaboration with the different weather-sensitive stakeholders. For example, we have a collaboration on the extreme hot weather situation. So we not only map out the temperature situation during the extreme hot weather situation, but also we work on the heat-related mortality, morbidity situation, so we can find out who is a population, who is a vulnerable population, and what is the consequence of such kind of climate change situation in the next 20 to 30 years. And also, apart from this, we can inform the government what is the potential extra energy consumed by the extreme hot weather situation. So they can also work on the energy saving plan accordingly. And the last one is they focus on this kind of social media development because we need to provide this kind of AI, the big data, smart city, cross-sourcing through the various kind of weather services to let people know this kind of weather information. And I hope you can learn from our Hong Kong case. The take-home message, we hope we can summarize from the following points. Based on the previous this kind of experience, we realize the climate partnership is so important. So the city need to consider to develop this kind of partnership to form intergovernmental department liaison and also collaborate with the different stakeholders. And as we know, the changing climate will bring more the challenge and the risk to our city. So the more important how to make our city resilient and also the climate ready city. So this kind of weather forecast service and also the warning system have to consider to be developed so they can cope with extreme events. And also more important, we need to provide this kind of scientific basis to support the policy formulation. And the next one is general education and communication. For example, in Hong Kong, right now we have this kind of extreme hot weather events, and we need to let people realize this kind of extreme hot weather is a silent killer. You need to well prepare for this kind of extreme events. So that is why we need to, through the different communication engagement, to increase the public awareness. And the next one is about the data accessibility and availability. So we need to provide this kind of online information platform, mobile apps for various users and sectors. So this kind of data accessibility and availability will enhance the potential collaboration opportunities, and also let us know what is the potential users and engagements. And the last one, but more important, is this kind of research development and the capacity development. Like the Gerald presentation, as a co-part of the IUS, the research development and capacity development is very critical to increase such kind of interdisciplinary collaborations. The last but not least, we would like to thank the different departments provide this kind of data and information. Thanks for your attention.
Thank you, Chao. And this is really an amazing example where you can see how deeply and intimately different elements of the services are connected and how many sectors could be actually addressed at the same time using the same system, the same observing and modeling system. Chao, I will not ask you the question because we are kind of running out of time. There is a question in the chat for you about the greenhouse gas emission levels. If you can address it in the chat, that would be really great. And I will just introduce our last speaker of the session, Valérie Messon, who is a senior researcher at the National Center for Meteorological Research at Météo France in Toulouse. And he developed the urban climate numerical model, which is currently used by more than 20 countries in Europe. He is also our actively publishing researcher with about 100 peer-reviewed papers, and he contributes to the multiple groups within the World Meteorological Organization. So I would like to invite Valérie to give us another example how those integrated urban services are realized in French cities. Valérie, please.
Thank you, Oksana, and good evening and good morning to everyone, depending on where you are. So I will give you some examples of urban climate services that were done in French cities. So I will focus on mostly.
I'm sorry, Valérie,
yes?
could you please move to the presenter mode because we can see your 2 slides on the screen. So just switch to another mode of presentation.
I don't know how to do this. Is it okay?
Yes, now it's wonderful. Thank you.
I will mostly focus on urban heat and summer impact of weather in cities. And for this, I will talk about the mitigation of the urban heat island. So the urban heat island is the fact that temperature can be much larger in cities than in the rural areas, especially at night when we are in clear and calm conditions. So for example, some cities can be 10 degrees warmer than the countryside at night. And here you can see measurements of an urban heat island in summer in Toulouse. So it was long ago, it was in 2004 during an experiment, a research experiment. So there are a lot of climate services that are now being developed in France in relation to the mitigation of the heat stress in cities. So I will present 3 of them. The first 2 are on the co-conception of an observatory of the urban climate and on an emergency response. And in these 2 examples, the message is that the stakeholder has to be involved, and also that the stakeholders wants to have some information, ground truth on their territory. Now, about the co-construction of an observing network, there is the stakeholders, the city needs to know what the local climate is, especially to reduce the vulnerability to extreme events like heat waves, but also it can be on flooding, to optimize the energy consumptions, and to take these issues in the urban planning. So at the research center of the Med Service in France, we worked with the city of Toulouse to determine where to place meteorological stations within the city, because by default, as Gérald said, meteorological stations are outside the city. So for example, for Toulouse, you had only 2 meteorological stations at the 2 airports. So the idea of the city was to develop by the administration a meteorological network, and so they asked us to help them to do this and to add 60 stations within the city. So this is what is done there. And when discussing with them and so on, we decided where to place the stations and also where to observe warm points or cool points in the city. And on the figure on the right, you can see the dots are the meteorological stations, and the line is measurements done with an instrumented car to determine what were the additional points we needed to observe to have more details on the temperature fields in the city. And this led to an observing network that is now operational in the city of Toulouse, operated by the city of Toulouse. So this is an example of this summer on the 9th of August at midnight with a large urban heat island with cool areas, especially in the forests in the west, and warm areas in the city and the suburbs. And these are all the small figures are the meteorological stations. So this was possible because of an involvement and a will of the city to start to observe their own microclimate. So this is a proactive move from their part. And this is also what is done with in the case of the city of Paris for the second example. So Paris, there was a disaster in 2003. It was a famous heat wave in Europe, and there were a lot of dead in Paris because of the heat. And since that time, the city of Paris wants to mitigate the heat stress and improve the heat thermal comfort of people in summer. So in Paris, the urban interior can reach 10 degrees by night. And because it is caused by the artificialization, there may be some adaptation strategies to add some, for example, vegetation when it is possible. But Paris is sometimes very dense city, and it's not possible to add much vegetation there. So since 10 years ago, the city of Paris started to study with a laboratory of Paris University what would be the effect of watering the roads. So this is something that is done classically since very long ago in Japan to improve the weather in summer, but it's typically a new practice in the city in Europe, and they wanted to test on their site with their type of roads and so on, what is the effect of watering the road and what is the more efficient process to water them. So they use some trucks to water the road, and they want, does the truck has to come there every 30 minutes or every hour and so on. And they tested it with 3 PhD theses they have done with the university, and they installed some meteorological stations and so on. And now they are studying. They know that watering the road, they know how to optimize the use of water for this. It can reduce the heat perceived by the people by 2 to 3 degrees. So this is a net gain in summer during the afternoon. And now they are studying where they should apply these techniques and where are the most vulnerable areas in the city. And then the last example is more complex, is on the evaluation of adaptation scenarios for cities. And to do this, we worked with the urban planning agencies and focused on the long term, because climate change is long, but cities will also stay for a long time. And so we have to study the impact of coevolution of the city and the climate. So there are main large-scale drivers that are on the left. So climate change, the macroeconomy, and the population, the demography. And macroeconomy can lead to city evolution, climate change, impact urban planning, but also meteorological processes, and so on. And demography and population can, the people have some behaviors. They can want to use air conditioning to improve their human comfort inside the buildings and so on, but this leads to waste heat that can heat the city further and so on. So the question, this is just a small part of the main processes that are that we should take into account when we study the interaction of cities and climate change. So to do this evaluation of adaptation strategies to climate change, we use urbanized atmospheric models, where the atmosphere is gridded with a lot of grids and with schematic representation of the urban surface and vegetated surface below. So using such numerical tools, we can evaluate the impact of several adaptation strategies. And the first one is, well, we could use air conditioning. Well, of course, air conditioning is not a good solution because of the increased energy consumption, but also because it takes the heat inside and put it outside. So it can increase even more the urban heat element of the city. So it's not the main cause of the urban heat element, but it can increase it by 1 or 2 degrees. So such studies have been done over Tokyo too, and they found the same order of magnitude. So there are other levers that can be used to combine adaptation and mitigation. And for when we think about summer thermal comfort, there are emergency practices, as I showed just before, but also building renovation, urban vegetation, but in link with water resources, large-scale urban planning, evolution of behavior of people that can be very efficient, especially on the, for example, the setting of the air conditioning temperatures or domestic heating in winter and things like that. So the main point is that there are a lot of scales, a lot of actors that have to be considered or to take into account the effect of the adaptation strategy. So here are some examples of if we have green roofs, what we have found is that it can contribute to building insulation, but it has very small effect on the pedestrian comfort. On the contrary, ground vegetation and trees are much more efficient to cool the air. And if we had some significant greening in the Paris area for all available spaces like car parks, sidewalks, places, so we do not change the roads, we do not change the buildings, they are there, but adding some vegetation can cool the air by 1 to 2 degrees in summer. There are also possibilities to think of what happens outside the city. So the city can be warm because the countryside is warm. And changing the agriculture can lead to increased evaporation. For example, when we use local vegetable farming instead of cereals. So we modeled that this could cool the air in the city by a further 2 degrees. And finally, to conclude, we also studied the link between city expansion and climate change. So this is the example of an urban heat island for a sprawled city, like what we have today, typically in Paris. And this is more for a compact city. So the urban heat island, as you see, is not that different. But in a compact city, people are more in the city center or near where the temperature is warmer. And so people are more impacted by the urban heat in compact cities. So there are always some trade-offs to consider when we want to work on urban planning. So the urban planners, they know that compact city can help to reduce the transportation, maybe, can help to reduce the energy consumption, but there are some other effects on thermal stress. So all this needs to be communicated to actors, to urban planners, to city administrations, and so on. So this is also something that is very important. That is in general done with social scientists and with even lawyers in environment and so on. And this is some aspects we have done on how to transfer information to the city and how to work on recommendation guides and so on. And just to conclude, so one of the recommendation guide is the one that was done by WMO. And as Stephanie said, so the first thing is that it is important not to wait for a disaster to act. So that's what has been done, for example, for Paris with the heat wave, but we can learn from that. And also another thing I want to say is that it's not easy for a city to start with a very complex and completely integrated urban service at the start, and start with something more smaller, with an observatory or things like that can help to start the process of more integrated services later on. Thank you.
Okay. Thank you, Valerie. This is a very nice presentation. I think that we are running out of time and there is no more time for questions. So the next session starts and in 1 minute. But if in 1 minute you can, maybe you and Chao, just a very short answer to the short question. When you work in the very densely populated area, what do you think about those promoted nature-based solutions where you have concrete buildings?
Oh,
a short reflection on that.
Yeah, I think it's a very effective solution because it works against the main cause of the urban hinterland, which is artificialization, and it has a lot of benefits that are not on climate, but that are on the stress of the people, on social interaction, and so on. So I think it should be promoted when possible.
Thank you, and Chao, your reflection on that, briefly.
In Hong Kong, for us, first we map out what is the urban climate resources at the city level and point out the problem and the sensitive area. And the second step is we already have such kind of high dense, high-rise urban context. So we need to understand what is impact of such kind of built environment in terms of the climate and also this kind of health impact. So that is the key steps we work on in Hong Kong.
Thank you very much. I think it was a really great session, and I would like to thank all the speakers. Or I would like to ask all the participants who have questions to the session to send me the questions directly, and all of the speakers are working in our study group on integrated urban services, and we can bring it to the attention of that group. So I have my email in the chat, so you can send me the messages and we can discuss this further. Thank you very much, and thank you for your participation in the session, and I hope that you learn a lot about integrated urban services and you are very excited to see how that can be implemented in your city. Thank you very much.